You're standing outside on an ordinary afternoon. The sky is clear, the air feels normal, and everything seems exactly as it should. Then, without warning, the sun begins to disappear. Not behind a cloud, not behind a mountain. Something dark seems to consume it piece by piece until daylight fades into an eerie twilight. Birds stop singing. The temperature drops. Shadows sharpen into strange crescent shapes. For a few unforgettable minutes, day becomes night. Now imagine you have no idea why. You know nothing about orbits, gravity, or the moon's shadow. You don't know this will end in a few minutes. All you know is that the one constant in your life, the sun that has risen every morning without fail, is vanishing before your eyes. What would you feel? What would you do? That question takes us back tens of thousands of years to the first human beings who witnessed a total solar eclipse. We have no written account of that first eclipse, and no name for the person who saw it. But we don't need one. The human brain inside your skull is remarkably similar to the brain your ancestors carried 50,000 years ago. Strip away everything you know about astronomy, and you're left with the same instincts they had. And those instincts would not remain calm. To understand why, you have to understand how early humans understood the world. Their lives depended on patterns. Sunrise, sunset, the phases of the moon, the changing seasons. These weren't just interesting observations, they were survival itself. They told people when to hunt, when to gather food, when rain might come, and when winter was approaching. So when one of those patterns shattered in broad daylight, the response wasn't curiosity, it was fear. Psychologists describe this as pattern violation, the intense distress that occurs when a deeply trusted rule suddenly fails. Research into human cognition, including work by psychologist Daniel Kahneman, shows that our brains are built to expect consistency. When reality suddenly breaks those expectations, especially without warning, the brain doesn't simply label it as surprising, it treats it as a possible threat. This idea reaches far beyond eclipses. Your mind constantly builds a model of how the world works. The sun rises every morning, rivers flow downhill, night follows day. Those expectations allow your brain to predict what comes next and prepare for danger before it arrives. When something as fundamental as the sun suddenly disappears, that internal model collapses. Instead of calmly updating itself, your nervous system reacts as though the world itself may no longer be safe. Your heart beats faster, your attention narrows, your body prepares to act, even if there's nothing you can actually do except stare upward. A total solar eclipse is already extraordinary to someone who understands it. Without science, it would be almost unimaginable. The bright sun slowly shrinks into a thin crescent before vanishing behind a perfect black disk. Darkness spreads across the land far faster than any sunset. Stars appear in the middle of the day. The air cools within minutes. Wind patterns shift. Birds fall silent. Nocturnal insects begin singing. Even the colors around you seem unnatural. Long before your conscious mind could invent an explanation, your body would already be responding. The nervous system doesn't wait for logic. It reacts directly to changes in light, temperature, and sound. And during an eclipse, every one of those signals says the same thing. Something is terribly wrong. Modern research shows that humans aren't alone in responding this way. During the 2017 total solar eclipse across the United States, scientists observed dramatic behavioral changes in roughly 3/4 of the animal species they studied. Birds stopped flying and became silent. Crickets began chirping as though night had arrived. Cattle started walking toward their barns in broad daylight. Several species displayed signs of confusion or anxiety normally associated with danger. Animals don't understand astronomy. They simply respond to the sudden collapse of normal environmental cues. Now imagine a human ancestor with the same instinctive reactions, but also with language, memory, imagination, and the ability to create stories. That combination made eclipses even more terrifying. The earliest written records of eclipses weren't scientific explanations, they were warnings. In ancient China, people believed a celestial dragon was devouring the sun. According to tradition, 2 royal astronomers were executed after failing to predict an eclipse because the emperor believed such events threatened the stability of his rule. In Mesopotamia, Babylonian priests treated eclipses as ominous messages for the king. During especially dangerous eclipses, they sometimes placed a substitute king on the throne to absorb the coming disaster while the real ruler remained hidden. Different civilizations created different myths, yet nearly all shared the same emotional conclusion. The sky had broken its promise. Something powerful was attacking the sun. Something had been angered. Someone would suffer. Long before dragons, kings, or written language, our earliest ancestors still needed an explanation. Picture a small group standing together as daylight fades into darkness. No astronomer tells them the eclipse will end in 4 minutes. No one understands what they're seeing. Maybe the sun is dying. Maybe the world is ending. Maybe an unseen force has awakened. When knowledge is absent, the human brain rarely leaves an empty space. It fills the gap with the explanation that feels most urgent, and that explanation is often frightening. Remarkably, your brain still works the same way today. Whenever you face uncertainty, your mind wants an answer. A wrong explanation often feels more comfortable than no explanation at all, because uncertainty itself feels dangerous. There's a good evolutionary reason for that. For most of human history, assuming danger when none existed usually carried a small cost, but assuming safety when danger was real could be fatal. Evolution favored the ancestors who reacted first and investigated later. An eclipse rare, overwhelming, and completely unexplained was almost perfectly designed to trigger that ancient survival system. But here's the remarkable twist. The same terrifying event that once convinced people the world was ending eventually helped humanity understand the universe itself. Unlike many natural disasters, eclipses repeat in predictable patterns. After centuries of carefully recording them, Babylonian astronomers recognized one of those patterns, now known as the Saros cycle. Roughly every 18 years, similar eclipses occur again under related conditions. What had once seemed like divine punishment slowly became information. That realization marked one of history's quiet revolutions. Instead of fearing the sky alone, people began observing it. Instead of relying only on stories, they started recording measurements. Fear slowly transformed into curiosity. Generation after generation, careful observation proved more powerful than panic. Centuries later, eclipses became indispensable scientific tools. Astronomers used them to study the sun's faint outer atmosphere, the corona, normally hidden by the sun's brilliant light. They refined measurements of Earth's rotation and improved our understanding of celestial motion. Then, in 1919, a total solar eclipse provided one of science's greatest tests. By photographing stars near the darkened sun, astronomers measured how gravity bent starlight, confirming Albert Einstein's theory of general relativity. An event once blamed on dragons helped verify one of humanity's deepest insights into the universe. So what does all this mean for you? Today, you understand exactly what's happening during a solar eclipse. The moon passes between Earth and the sun. Totality lasts only a few minutes before daylight returns. There is no monster swallowing the sun. There is no divine punishment. Yet something ancient still awakens. People who experience totality often describe an emotional reaction that feels strangely primal. Their pulse quickens. The hair on their arms stands up. Many cry without fully understanding why. Logic explains the eclipse, but instinct still whispers that something impossible is happening. That reaction isn't a flaw. It's an inheritance. It's the same ancient alarm that once drove our ancestors to search for answers. The same instinct that transformed terror into observation, observation into astronomy, and astronomy into science. Perhaps that's the real lesson hidden inside every eclipse. Fear itself wasn't the enemy. The discomfort of not knowing became the motivation to understand. Every star chart, every eclipse prediction, every Saros table, and every scientific discovery began because someone looked into the darkness, admitted they didn't understand it, and refused to stop asking questions. So, when the sky grows dark in the middle of the day and you feel that brief flicker of unease, remember that you're experiencing more than a beautiful astronomical event. You're sharing a feeling carried across thousands of generations. For a few extraordinary minutes, you're standing where your ancestors once stood, watching the most reliable object in their world disappear. They didn't know the light would return. You do. And that difference, the journey from fear to understanding, is one of humanity's greatest achievements.